in chemistry, when you run an experiment, you come up with a certain amount of product that you were able to create. So the reality is that what you make in the lab is never as much as you should have been able to make based on your calculations. And that's where percent yield comes in. We want a way to compare what we made to what we should have been able to make to see how accurate our experiment was. When I talk about actual yield, I'm talking about the amount of product that you actually made during a chemical reaction. The only way to find out the actual yield is to do an experiment. So if you're reading a problem and it says something was created in a lab, you know you're talking about the actual yield, what was made in reality. The theoretical yield is how much you should have made if everything went perfectly. It's the maximum amount of product that you could form given the amounts of your reactants. You have to calculate the theoretical yield. This is what you get with pen and paper. And then the percent yield is a ratio or a comparison of the actual yield to the theoretical yield, and it's expressed as a percent. So it's the actual yield in grams divided by the theoretical yield in grams times 100, which turns it into a percentage. The closer you are to 100%, the more accurate and your experiment was. Like I said, the reality is you never can get a 100% yield for a variety of reasons. Maybe you spilled some of your product. Maybe you spilled some of the reactant. Maybe the mass wasn't calibrated correctly. Maybe your partner mixed incorrectly, or the reaction didn't run through to completion. For whatever reason, you never get a 100% yield. We'd like to get as close to 100% as possible by minimizing the sources of error in our lab. So let's look at some examples. A chemical reaction has the potential to create 124 grams of HCl. So it has the potential, that means it's the theoretical yield. Theoretical yield is 124 grams. But in the lab, the student created 59 grams of HCl. What is the percent yield? So we see the key word here in the lab is 59 grams. That's what we made in reality. So our formula is actual yield divided by theoretical yield times 100. And we find out that the student had a 47.58, so we could round. We could say 48% yield if we're being generous here. That's not a very effective, that's not a very effective lab that he ran. So something major happened with his calculations. Another experiment that you might see gives you the reactants and has you calculate what you should have been able to create. So calculate the theoretical yield. A student conducted a chemical experiment to determine which chemical reaction would occur when a solution of silver nitrate was mixed with a piece of nickel. It produced small pieces of solid silver and a solution of nickel 3 nitrate. What is the percent yield of silver produced for the reaction? All right, we have a lot going on here. Let's break it down. Let's start by balancing our equation. So 1 Ag on the left, I have 1 silver on the right, 1 NO3 on the left, 1 NO3 on the right, so let's balance that. And then now that changes my silver, so let's change our silver. So if I balance correctly, it should have coefficients of 3, 1, 1, and 3. So the empty filter paper had a mass of 0.78 grams. The filter paper with the silver was 1.26 grams. Let's find the mass of the silver alone. So 1.26 minus 0.78. And we actually produced 0.48 grams of silver. We used 1.53 grams of nickel in my reaction. I want you to calculate the theoretical yield of silver based on 1.53 grams of nickel. So to do that, that's a gram to gram stoichiometry. 1.53 grams of nickel, and we have to turn that ultimately into grams of silver. First step, let's turn grams of nickel into moles of nickel. Nickel has a molar mass of 58.71 grams in 1 mole of nickel. Next, I can use my mole ratios to convert nickel into silver. There is 1 mole of nickel for every 3 moles of silver. And finally, I need to turn moles of silver into grams of silver using my molar mass. So silver has a molar mass of 107.87 grams of silver. Oh, I take that back. I'm putting that in the wrong spot here. It's 107.87 grams. Let's erase that. In 1 mole of silver. So multiply across the top, 1.53 times 1 times 3 times 107.87. And then divide by the bottom, so divide by 58.71. And I should have created 8.4 grams of silver. That's my theoretical yield of silver. The reality is I only created 0.48 grams. So 0.48 divided by 8.43 times 100. And that was only a 5.7% yield. Let's look at another problem that's very similar. A student placed a piece of zinc in a flask and added HCl to it. He placed a balloon over the flask to capture the hydrogen gas. What is the percent yield of hydrogen gas captured in the balloon? Let's balance our equation. The mass of the empty balloon was 2.5 grams. The mass of zinc used was 8 grams. And then the mass of the balloon with the hydrogen gas was 3.25. So let's find the actual yield of hydrogen gas. 3.25 minus the 2.5. The actual yield was 0.75 grams of hydrogen. And now let's calculate the theoretical yield of hydrogen based on the zinc that we used. So we used 8 grams of zinc. We need to turn grams of zinc into grams of hydrogen. So first turn our grams of zinc into moles of zinc using the molar mass. Zinc has a molar mass of 65.38 grams in 1 mole. Let's turn moles of zinc into moles of hydrogen. That's a 1-to-1 mole ratio. And now let's turn moles of hydrogen into grams of hydrogen. There are 2 grams of hydrogen gas in every 1 mole of hydrogen. That's my molar mass of hydrogen. So let's multiply across the top, 8 times 2, divided by the bottom, 65.38. And I should have been able to produce 0.24 grams of hydrogen. So let's calculate the percent yield. The claim is that we made 0.75 grams of hydrogen, and our theoretical yield was 0.24 grams. So 0.75 divided by 0.24 times 100 is 312.5%. So if this was my experiment and I'm looking at these numbers, something is not right here, because it's not possible to obtain greater than a 100% yield. I would start to problem solve and think, maybe what happened? How did I get a greater mass of hydrogen? It's possible that there was air in the balloon before you put it on top of the flask. There's a variety of reasons that our actual yield claims to be higher than our theoretical yield.